So we're given two perpetuities with the same payments and the same interest rate, and we're asked to find the payment amount. First, we need to find the interest rate. So let's look at our two perpetuities. Here's perpetuity 1. The payment, which we don't know, we're just going to leave it a variable called P, starts in period 1 and continues every period thereafter into the future, forever. Perpetuity 2 has the same payment as perpetuity 1 and the same interest rate. It's just the first payment begins in year 25 instead of year 1, and it goes on every year thereafter, 26, 27, forever into the future. We're told that perpetuity 2 is worth $7,809.375 in year 24. But remember the equation for the value of a perpetuity. It's the value in year 0 is equal to the payment in year 1 divided by the interest rate. It doesn't matter explicitly that it's the value in year 0 and the payment in year 1. The point is, when you calculate the value of a perpetuity, you start with the payment that's the first payment in the year where the perpetuity begins, divided by the interest rate, and then you get the value of the perpetuity evaluated at the period before the first payment. So we can see here the reason they give us the value of the second perpetuity in year 24 is because it's the year before the first payment. So they're using this formula. Since both perpetuities have the same payment and the interest rate, we'll get the same answer for the value in year 0, just in a different period. So perpetuity 1, again, the formula for the value of a perpetuity is only based on payment and interest. Since these two things are identical between both perpetuities, we'll still get the $7,809.375. It's just that in perpetuity 1, it'll be the value in year 0, because year 0 is one period before the first payment. The first payment occurs in year 1 in perpetuity 1, and it occurs in year 25 in perpetuity 2. So we know that the annuity is the difference of the two perpetuities, but we have to evaluate the value of the two perpetuities in the same period. Right now, one is in year 0 and one is in year 24. The question gives us the value of the annuity in year 24. So let's find what perpetuity 1 is worth in year 24. Let's just compound that forward. So the value of perpetuity 1 in year 24, well, we start with the value in year 0, the $7,809, and we just compound that forward by multiplying it times 1 plus r, the interest rate, raised to the 24, because there are 24 periods between year 0 and year 24. We have to leave r, the interest rate, as a variable, because again, we don't know what it is. But now that we have expressions for both perpetuities evaluated in year 24, their difference will be the value of the annuity in year 24. So again, the value of the annuity in year 24 is perpetuity 1 in 24 minus the value of perpetuity 2 in 24. We're given what the annuity is worth in 24, what perpetuity 2 is worth in 24, and we found what perpetuity 1 is worth in 24. So we can plug these in. We're told the annuity is worth $41,711, and we found the expression for perpetuity 1 in year 24 to be $7,809 times 1 plus r raised to the 24, and we subtract off the value of perpetuity 2 in year 24, which is just the $7,809. And so we have an expression here, which we know holds with equality because of the equal sign, but we only have one variable, the interest rate r, so we can solve for that. First, we want to add the $7,809 to both sides to eliminate it, and then we want to just divide by the $7,809. That's the coefficient on the 1 plus r raised to the 24th power. And we get 6.34 equals 1 plus r raised to the 24th power. To get rid of that 24th power, we just raise both sides to the 1 over 24th. It gets rid of the exponent on the side with the 1 plus r, and we just have to evaluate it on the other side. 6.341180735 raised to the 1 over 24th power is 1.08. Last thing we have to do is just subtract the 1, and we see that the interest rate that's used to find the value of these two perpetuities must have been 8%. Now that we have found the interest rate, we can solve for the payment easily using either original perpetuity and the equation for the value of a perpetuity. So again, the value of a perpetuity in year 0, or just the year before the first payment begins, is equal to that payment amount divided by the interest rate. And so we know that the value of either perpetuity the year before the first payment begins is $7,809. So we set that equal to the payment divided by the interest rate, which we just found to be 8%. Again, here we have to enter the interest rate as a decimal, 0.08. And we can just solve for payment, and we see that the payment is $624.75.